Tonight, Jupiter is there, massive, the largest thing in this solar system, outside the sun itself. It has been sitting in that same spot for 4 billion years, and then it isn't. No warning, no countdown, nothing. The king of our solar system just disappeared. What follows is something no one on Earth is ready for. Stay until the 18-minute mark, because what happens to our orbit is something no textbook has ever shown you. Before we lose Jupiter, let's actually establish what we're losing. Most people think of it as a big planet with a storm on it. That's underselling it by a lot. Jupiter is not just large. It's the gravitational anchor of this solar system, second only to the sun. It holds more than twice the combined mass of every other planet, moon, asteroid, and comet out there, all added together. That mass produces gravity, constant, invisible, and enormous. For 4 billion years, that gravity has been running the most important maintenance function in the solar system, keeping things stable enough for life to exist here. Between Mars and Jupiter sits the asteroid belt, roughly 1.1 to 1.9 million objects larger than 1 kilometer across, billions of smaller ones. This is leftover material from the solar system's formation. It never coalesced into a planet because Jupiter's gravity kept breaking it apart. And right now, that same gravity keeps it from going anywhere. Think of Jupiter as a bouncer, a 1.96 trillion kilogram bouncer who hasn't taken a day off in 4 billion years. In 1994, the world watched live as Comet Shoemaker-Levy 9, broken apart into 21 pieces, hit Jupiter. Each impact was larger than Earth. Scientists later worked out that this comet was heading inward through the solar system toward Earth. Jupiter absorbed every single hit. Jupiter saved us in 1994. We barely paid attention. But the job doesn't stop at catching comets. Jupiter's gravity helps stabilize the outer planets. Saturn, Uranus, Neptune are all locked in gravitational resonance with it, a relationship that has held steady for 4 billion years. Earth's orbit is shaped by this too. Jupiter keeps our path around the sun close to circular. Without it, the orbit would stretch into a longer, more elongated ellipse. Without that stabilizing force, summers on Earth would be lethal. Winters would be extinction-level cold. The Romans named this planet Jupiter, king of the gods. They were more right than they knew. And this was all before it disappeared. Wait until you see what happens 43 minutes after. It happens at 11:34 p.m. a Tuesday. At a research facility in Chile, a junior astronomer named Priya is running routine planetary tracking. Something is wrong with her numbers. She refreshes the data, checks the instrument calibration, refreshes again. Then she types a message to her supervisor. 4 words. Within 12 minutes, observatories on 4 continents have confirmed the same reading. Within an hour, NASA sends an emergency internal alert. Within 3 hours, it's the only story on every news channel in the world. Let's be precise about what vanished means here. This is not an eclipse, not a sensor error. Every gravitational detector on Earth is showing the same thing. A planet of 1.96 trillion kilograms no longer exists. Nobody has an explanation. And here's where it gets physically strange. Jupiter sits roughly 43 light minutes from Earth right now, which means we didn't lose Jupiter at 11:34 p.m. We lost Jupiter 43 minutes before 11:34 p.m. The gravitational change has been moving outward at the speed of light for almost an hour. The solar system registered the loss 43 minutes ago. It's already reacting. In the next section, I'm going to show you something that will genuinely make you uncomfortable about the night sky you're living under right now. Hour 1. Nothing is visible to the naked eye. But at JPL's supercomputer facility in Pasadena, the orbital simulations have been running for 60 straight minutes, and the outputs are making people physically sick. The asteroid belt is already shifting. Jupiter's gravity, the force that held billions of objects in their lanes for 4 billion years, is gone. The objects aren't immediately chaotic. They don't start shooting inward. Gravity doesn't work that fast, but they are drifting, slowly, steadily. Think of passengers on a ship the moment the captain lets go of the wheel. Nothing dramatic in the first few seconds, but nobody steering anymore. Saturn is already registering the change. For billions of years, Jupiter and Saturn have been in what astronomers call orbital resonance, a relationship where Saturn completed exactly 2 orbits for every 5 of Jupiter's. That 5-2 resonance was a foundational piece of outer solar system stability. It's now gone. Saturn starts drifting outward, slowly, measurably, without stopping. 12 hours in, the models at JPL agree on everything. Over 2,000 asteroid belt objects have already shifted their orbital paths. The first of them will cross Mars's orbital path within months. The first will reach Earth's orbital neighborhood within a few years, and hundreds of thousands more are behind them. 24 hours. World governments have been briefed. The public doesn't have the full picture yet, and in the night sky, where Jupiter used to blaze brighter than any star, there is nothing, just a dark patch where something used to be. 30 days. For the first time in history, every major space agency on Earth is functioning as one operation. NASA, ESA, Roscosmos, CNSA, ISRO, JXA, all sharing data in real time. No classification restrictions, no geopolitical friction, just orbital mechanics, asteroid tracking, and a collective understanding of what's coming. The Planetary Defense Network has flagged over 3,400 objects with significantly changed orbital paths. Most are small enough to burn up on atmospheric entry. Some aren't. To put that in perspective, the asteroid that killed the dinosaurs was roughly 10 to 15 kilometers wide. It released energy equivalent to about 1 billion Hiroshima bombs. It ended 75% of all species on Earth. There are objects in the asteroid belt bigger than that, and nothing is holding them back anymore. Month 1 also brings confirmation of something the models weren't supposed to show this soon. Earth's orbit is changing. The shift is small right now, fractions of a percentage point, but the direction is clear. Our orbit is stretching into a more elongated ellipse, and without Jupiter's gravity pulling it back into shape, the models say it will keep going. Month 1 is also when most people feel it for the first time. Not through a news alert, not through a science briefing, just by going outside at night and looking up. Something is missing, something that was always there, something they never really paid attention to until now. We are 3 months in. What happens in year 1 makes everything so far look like a warm-up. Keep watching. 1 year. The first wave is here. Earth's atmosphere earns its keep. On some nights, the sky is on fire. Meteor showers that dwarf anything in recorded human history. Tens of thousands of objects burning up on their way down. People stop on street corners to watch. Some are terrified. Some have never seen anything more beautiful in their lives. Scientists already have a name for what's beginning. The Late Heavy Bombardment was a period roughly 3.9 billion years ago when asteroid and comet impacts spiked catastrophically and held there for hundreds of millions of years. It melted oceans, wiped out entire continental formations, reset the conditions for life more than once. The long-range simulations say we may now be in the early stages of something like it. Year 1 also brings the first major impact. A 200-meter asteroid hits the North Atlantic. The energy released is roughly equivalent to 1,000 Hiroshima bombs. The tsunami that follows wipes out coastlines from Iceland to Portugal. Thousands dead, millions displaced. Planetary defense missions go up within months of Jupiter's disappearance. Deflection payloads, kinetic impactors, nuclear standoff detonations. Some work, some don't. But here's what no government briefing can change. The asteroid belt holds an estimated 1.1 to 1.9 million objects larger than 1 kilometer. Earth's planetary defense network, running at full capacity, with every space agency working together, can handle hundreds of threats at once. Not hundreds of thousands, not millions, and things in the belt are only getting more chaotic. That was year 1. Wait until you see what happens over the next 100 years, because your orbit is never the same again. Over decades, over centuries, the solar system slowly stops resembling what it was. Earth's orbit grows more elongated every decade. The gap between our closest and furthest points from the sun keeps widening. Summers get worse, winters get worse, and then there's the axial tilt. Jupiter's gravity helps hold Earth's axial tilt stable at around 23.5 degrees. That tilt is what gives us seasons. Without that stabilizing pressure, over millions of years, the tilt can migrate. If it reached 90 degrees, the way Uranus sits, our poles would face the sun for half the year. Nothing like modern complex life has survived temperature extremes like that. Saturn drifts outward, looking for a new equilibrium it won't find. Its rings, which astronomers have spent centuries studying and painters have spent centuries dreaming about, start to come apart. And the asteroid belt, in 1,000 years, it isn't a belt anymore. It's a dispersed field of debris across the inner solar system. Some objects fall into the sun, some get thrown out into interstellar space, some fall toward the planets, and it doesn't stop. So, the question you've been waiting for: could we survive? Short answer, maybe in the beginning. Humans are genuinely good at adaptation. If this happened, civilization would restructure itself around survival. Underground cities, deflection networks, agricultural systems built to operate in radically changed conditions. We did make it through the last ice age with stone tools and fire. But over centuries, over millennia, the numbers stop working in our favor. A civilization-ending impact becomes less of a question of if and more of a question of when. For 4 billion years, Jupiter was just there, silent, barely noticed, almost completely taken for granted. The whole time, it was running a protective function that nothing in our solar system asked it to run. It didn't choose this, it simply exists. And that existence happens to make ours possible, whether that's the most extraordinary coincidence in the known universe, or something else entirely. I'll leave that one to you. The universe is enormous, and in that enormity, the conditions that make life possible are rare. The right distance from a stable star, a moon the right size, an axial tilt that holds, and a gas giant sitting in exactly the right position, massive enough to matter, quietly absorbing the chaos before it reaches us. We live in a solar system that actually works, that is not a given anywhere. If this episode changed how you look at the night sky, subscribe to Cosmic Smash. The answer isn't what you'd expect. Until then, keep looking up.